Hello and welcome to this Parallax Quick Byte. Today we're going to have a look at the new Parallax P2 add-on RTC, a real-time clock. Let's have a look at the hardware I'm using in this demo. So there's the P2 mini breakout board, a P2 edge module, prop plug, and the barrel jack to USB cable to provide power. And of course the small cute little RTC plug-on shown there on the right hand side. You could use any P2 breakout board, you could use any of the currently two P2 edge module options, the one with the memory, the one without the memory. It doesn't matter for this demo, but this is the hardware I've used. So let's have a look at the code. I will just get to that here. So RTC example, you'll find this code as a download in the QuickBooks file. Now one thing that's important to note is that at the top of the code we have our timing section as usual, so we set the clock frequency that you want your project to run at. Here it's just set to 180 megahertz, 180 million. Set that as you wish, but what it would be important is the XIM frequency. We don't usually set that. If you don't set it, it does default to 20 megahertz, which is the value of the clock or oscillator that's installed on Parallax P2 boards, such as the Edge module, by default. So if you're using a standard Parallax board, you don't need to set this necessarily, but some third-party boards do use different clocks. 25 megahertz I've seen, 19.2 megahertz I've seen. So if you are using a I don't want to say non-standard, if you're using a different frequency for your oscillator, just set it here. And the reason that's important is because as part of this code we're going to calibrate the RTC module. The RTC module's clock is not as accurate as the P2 Edge module's clock, so it makes sense to calibrate the real-time clock to make it as accurate as possible. But to do that, we need to make sure that the system knows, exactly what frequency we're running. So that is that. Next thing is the base pin as usual. So I've just got that on base pin 16 in this demo, so we're good to go there. Now the code is here. All we do is we start the real-time clock. We give it the base pin and we set this parameter to true. This means to calibrate. You could set that to false if you didn't want to calibrate the clock, but why not? If it doesn't start, then we just tell it to halt because we don't want to go further. Next, there's an optional reset. You could call this command if your RTC clock gets into a real tiz-was. Maybe you've set some bad settings while you've been fiddling around with it. No problem. Just call RTC software reset. Next up, we check to see if the battery is low or not. These are all optional, by the way, but these are just functions that have been implemented in the driver, so just to point them out, you don't need to use these. But yeah, here we're checking if the battery's low, and we're going to halt if the battery is low. Next, we set to the battery mode. Now this one is worth doing at least once after you've received the battery from shipping, because whilst shipping the battery will be disabled, so we do want to just set the battery to enabled. Otherwise the thing will not keep time when you've stopped using it and unplugged it. Finally, just to point out that you could call RTC calibrate as an own function. I've set that to false here, so it's not going to save the calibration results. It's not needed here because at the start I've put true, so I've told it to calibrate right at the start. But just to point out that you can then call it later on in your code. If your system is running for a long time, you might want to call calibrate once a day, or as you wish, or once a quarter. Finally, this is how you can manually set the time and date. Set the time seconds, minutes, hours, as shown here, and the calendar, day, month, year, and then, well, the thing is set up, ready to go. I will show in another demo in a moment how to set the time from a GPS connection, which might be more useful because you're more likely to get it more accurate, I guess. So yeah, and then the demo section here, this just shows how you can consume the data from the RTC. So we just wait a second. We set up the debug terminal to show us date and time and day windows. And then here's the guts of it, really. So using these commands here, or certainly the first two, I guess, are going to be the most common. We just call RTC get time, and that will return three values. SC is seconds, MN is the minutes, and HR is the current hour. And then on the next line we call RTC get calendar, which returns the day, the month, and the year. The third one is weekday, so it will return a digit between 0 and 6, depending if it's Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And then this is just a working variable for this code. So we call those. So in your code, once you've got that, you could do stuff with those values. They're just going to be integers that you can use in your code. Here for this demo, we're just going to repeat in a loop, and we're just going to show them on screen. So here we display the calendar details, the time details, and here we display some details about the day. And that's it. So if I run the code, you'll see what that output looks like. Let's press F10, and you'll see the debug window pop up, and it's setting up various things, and then the clock there is ticking away. So you can see now we've now got the time ticking. Now that's as simple as that. You can see actually this is a leap year I've chosen, so we've got day 340 of 366. Had it not been a leap year, yeah, that would have been 365. So I'll just close that, and you'll see that with this code comes another file called the RTC driver, and in here you can see sort of the different options and the different public commands that have been implemented so far. If the thing is present, if the oscillator's ready, if the battery's low, software reset. You can change the different frequencies and things. Maybe don't get into that, but it's all there so you can read it through. And there's lots of text formatting operations as well that you can find a bit further down the code. You can display the time in various ways, 24-hour clock, 12-hour clock. So it's worth having a browse through, but the basics of it are those commands at the top. So you can find this product in our shop. Let me just switch over to that view. If you go to the shop and search for the product number, which is 64013, and there we go, and here's the product, view product, and yeah, there it is, ready to go. And you'll find underneath there's some downloads and resources, and here you'll find links to the schematic, to the data sheet of the RTC module. So if you really want to get into more details, you can find, and there'll be some code resources added here later as well. So hopefully that gets you started, and thanks for watching.